look at graphs of polynomial functions. I'm going to try to break this down for you so that you can follow along. There are going to be pieces to this, so there's a lot of information that is typed for you. So if you have a different color pen or if you have a highlighter, you're going to want to get that out because we're going to underline stuff that's going to be important that you're going to want to reference back to as you do your homework and as you study for this chapter, okay? So there's not a ton of fill in the blank. It's going to be more pulling out the stuff that we need. So first thing here is this definition. So when you have a polynomial that's written as the product of its factors, it's said to be written in, so we call this factored form. And so factored form you've actually done with quadratics, where you multiplied a and c, and then you got down to those two sets of parentheses. So that would be an example of factored form. Looks like this, right? This is factored form. This is called standard form. So it's important that you recognize the difference. When I see parentheses, factored form, when I just have that equal sign with the degrees, that's going to be standard form, okay? The blank of a polynomial function. So this is called, and I'm going to use two words here because you're going to see both. This might be called, you might be asked to find the zeros. You also might be asked to find the roots. Those are the same. So zeros and roots are the same as the solutions to the functions. Meaning, if this was my factored form up here, I could take all of those, right, and set them equal to 0 and find out what x is, and that would represent my roots or my zeros. Okay, and so this is what I was just saying up here. So I can take the zeros, and I can set each of the parentheses equal to 0. So if I did that here, so let me just go up to this so we can see. If I did that, I would take x minus 1 and set it equal to 0. And I would take x plus 2 and set it equal to 0. And then x minus 7, right, equal to 0. And so how many answers for x would I be getting right here? How many answers would I get when I solved? 3 different answers. So I would get x would equal 1 would be one answer. X would equal negative 2 would be a second answer. And x would equal 7. So when you did quadratics, and it was a parabola, meaning degree of 2, you got out 2 answers. When we're dealing with polynomials, we can have a degree of 3 or 4 or 5. We're going to get more than 2 answers. Okay? So let's just try this. So in example 1, this says find the zeros of the function. What form is this function in right here? Factored form. So once it's in factored form, I'm going to separate all parts and set them equal to 0. Now make sure you pay attention to this one out front. There's an x there, so I need to set that equal to 0. So I'm going to set x equal to 0. I'm going to set 2x minus 1 equal to 0. X minus 3 equal to 0. And x plus 5 equal to 0. And then we're going to solve each of these. The first one is done, right? X is going to be 0. That's going to be one of the solutions or one of the zeros or the roots. Let's solve this one. So I would add 1 to both sides. So 2x equals 1. And then I would divide by 2. So what's my other answer for x going to be? What would this one be? What? 1/2. Okay. And then over here, I would add 3. So x would equal 3. And then lastly, subtract 5. So x would equal negative 5. Okay? Now, do you remember when we did the quadratics chapter and you got out 2 answers for x? What did that mean for your graph? So think about a parabola. You got out two answers. What did it mean, those two answers, for your graph? So if you got out x equals -2 and x equals 5, it's where it crossed the x-axis. Okay, so how many answers do I have right here? 4. Are all of those real numbers? Meaning it could be on an x-axis, yes or no? Yeah, the only ones that aren't real would be if they were imaginary, right? So now you're going to start to see this polynomial function would cross the x-axis 4 times. Okay? So every solution I get out, so this is the next definition, the solutions of a function are where the graph crosses the x-axis, because you're getting out x equals, so it's where it's going to cross the x-axis, which are also called x-intercepts. X-intercepts is the same as crossing the x-axis. So in example 2, it says, find the zeros. So again, there's the vocab word. Find the zeros of the function graphed below. So if that's what they're asking us to find, if I do the first one for you here, they're saying, where is my graph crossing the x-axis? So I would put points where it is so that I can see it. And this is supposed to be a -4 over here, just so you're aware. Okay, so where are we crossing the x-axis? What's this first one right here? -3. So we're going to say x equals -3. There's one answer. Where's another one crossing? -1. Where's another one crossing? 0. And then the last one, it's not super clear, so you can make it up, make it easy. What would you call that one? 0.5, yeah. And so you can write your answer like this, where you say x equals for all of them, or if you want, you can just do this. Put commas and put all your answers down. So either option, okay? However you want to do it is fine. So this had 4 solutions, 4 zeros, because we crossed the x-axis 4 times. All right, I want you to do the next one on your own. Tell me the zeros of this function here. And did you get that the zeros are 2, 4, and 6? Everybody agree with that? Okay, so that's the first thing, is can you identify where the solutions are to a graph? So it's always where it crosses the x-axis. All right, so let's turn it over. Now, you have to know how your left side of your graph and your right side of your graph is going to work, okay? So we call this end behavior. And end behavior is going to describe the left side and the right side of your graph. So let me just show you what I mean by that by going back to that last picture. So here's what I'm saying. Does everybody see how on this graph right here, on the left side, I'm up here in the positives, and on the right side, I'm up here in the positives, right? Does everybody understand that? Okay, but now if you go over to this one, on the left side of my graph, if I was on this side of the axis, I'm going down in the negatives, right? This would go on forever. And then on the right side of the graph, I'm going up in the positives. So polynomials do different things based on the following information. So the first thing is your leading coefficient. Okay, so the leading coefficient is going to tell you what your right side is going to do. And this is something you're going to need to memorize, but you're going to want to have this out when you're doing your homework and when you're studying. So here's how it works. If my leading coefficient is positive, then the right side of my graph is going to rise. If my leading coefficient is positive, the right side of my graph is going to rise. If my leading coefficient is negative, the opposite is going to happen. Then my graph is going to fall to the right. Okay? So that's going to tell you the right side. So leading coefficient tells you right side. Now, the degree of your polynomial is going to tell you what happens on the left side. Okay? The degree is going to tell you what's going to happen on the left side. So here's how it works. If your degree is even, so that means it has a highest exponent of 2 or 4 or 6 and so on, then your left-hand behavior is the same as your right side. They will match. So if my right side rises, meaning going up, then my left side will rise. If my right side falls, my left side will fall. If the degree is odd, so if it's a degree of 1, 3, 5, so on, then my left hand will do the opposite of the right. And we're going to look at some examples of that as we go. Okay, so keep this table handy up here, all right, so that you can reference back. So here's what we're going to do. I'm giving you two polynomials in standard form, and I want you to tell me what the graph, what the end behaviors are going to do. So we're going to write it like this. So you're going to tell me what the right side is doing and what the left side is doing. And it's going to be as simple as saying, you can either say it rises or it falls. That's all you have to say. Rise, fall, okay? Now, before we do that, there's two things you need to know. First is our leading coefficient. So what's our leading coefficient for this one right here? What is it? Positive 4, okay? It's a positive 4. So let's start with that. So go back up to your table. If your leading coefficient is positive, what does that say about your right side? What's it going to do? It's going to rise. So I'm just going to write rise. Okay, the left side is off of our degree. What is our degree on this polynomial? What's the number? 3. It's 3. It's odd. So if it's odd, what does the left side do? It goes opposite of the right side. So if it's an odd degree, it's going to go opposite. So if this one was rise, what will this one have to be? Fall. So that means this graph, the right side would be going up, the left side would be going down, like that picture you already saw, right, where they were going in opposite directions. Okay, let's try the next one. So we're going to do the right side and then the left side. So let's start with leading coefficient. What is my leading coefficient on this polynomial? -2. If it's a negative, what is going to happen? It's going to fall. What's my degree? 4. So it's even. So if it's even, what's it going to do? It's going to do the same thing. It's going to match, which means it's going to fall as well. So again, people that are answering this, all they're doing is looking back up at that and rereading what it says. So you're going to have to go back to reference that often. And you're going to see how you're going to use this to actually graph. But you first need to be able to tell me in behavior by looking at equations. Does anybody have a question about that before we move? Okay, so here's some information in here. We're going to pull some stuff out. So get ready to highlight, underline, whatever. So here's what we have. Many polynomial graphs experience turning points or places where the graph is going to change from increasing to decreasing. So for example, Back to the beginning. Do we see here the graph was going down? All of a sudden it's changing, right? It's going up. Then it goes back down. Does everybody see what's happening? So these polynomials are constantly turning and having these turning points. Okay, so every quadratic graph has one turning point which occurs at the vertex. So this is something you guys learned in the last chapter. So let's just draw a picture over here. A quadratic, what was the shape of a quadratic? What did it make on a graph? A U, right? A parabola. So what happened was I would be decreasing, hit the vertex, and then I would increase. And so that represented, that vertex was a turning point. Okay? These turning points, so let's box that in or highlight. Those turning points can be called, and you learned this in quadratics, a maximum or a minimum. Now, here's the part that's new. When you did a parabola, your vertex was always the minimum of the graph, correct? Or the maximum of the graph. Does everybody agree with that? Your vertex always was. In this case, there's two types of maximums and minimums, and here's how they work. They can be relative, and that just means they are a high and a low point in their area. They're just high or low in that area, so I'll underline in their area. Or they can be absolute if they are the highest or lowest point that the function ever reaches. Okay, so let's do an example of that. So let's draw an arrow so you guys have a visual that you can see. All right, so let me give you one example. Let's just say this was my graph, okay? How many turning points does that graph right there have? Meaning where it changes going from increasing to decreasing. How many turning points? Has one, okay? What would you call that, a max or a min? This would be a max. Now, the question is this max a relative max, meaning it's higher in the function, or would you call it an absolute max, meaning it's the highest in the function? What would you call this? What? I heard somebody back there say. So what is that called? Is it relative or is it absolute? Absolute. This would be an example of an absolute maximum. Okay, let's say our graph looked like this. This time, how many times is that graph changing direction? Meaning, how many turning points does this one have? 3. So I would have like one here, and one here. Okay? What would this point be called? A max or a min? This would be a max. Well, hold on a second. What would this one be called? A max or a min? What is it? A min, because it's lower. And what would this one up here be called? A max. Okay, so let's look at the max. Is this an absolute or a relative? So is it the highest that the function goes, or is it just a higher point on the function? Is it the absolute highest that it goes? Yes, both of those are supposed to be the same. So if they don't look the same, pretend like they are. So that's the highest point of that function. So both of those would be considered absolute maxes. Now, what about our min? Is that the lowest that the function goes right there? No. Does everybody see that it's going forever and ever and ever, right? Down here. So that's not the lowest. So what would this min be? Relative. Good. Okay, so that's just an example. So you're always going to have maxes and mins. We need to be able to identify if they're relative or absolute. Okay, and then the last thing is that your graphs can have these turning points, okay? The most turning points they can have is this n minus 1, where n is the degree of the function. Okay? So if you look at this example right here, this polynomial, 2x cubed minus 5x squared plus 3x plus 3, would have at most how many turning points? So if you don't know, what's the degree of this polynomial right here? 3. So I would do 3 minus 1, which is 2. So that graph would turn at the most 2 times. And it could turn less than that, but at the most 2 times. Okay? Anybody have a question there? All right, so we're going to start doing some examples. So here we go. We're going to start with example 5. This is taking us back to the beginning. The question says, find the zeros. What form is this in? Factored form. When it's in factored form, what do you do to find those zeros? Set them equal to 0. Yep, and I have 3, so I'm going to set each of them equal to 0. So x plus 1 equals 0. X minus 1 equals 0. And x plus 3 equals 0. And then we're going to solve. So subtract 1. So x equals negative 1. That's one answer. Add 1. X equals positive 1. And subtract 3. X equals negative 3. So what do those two answers right there represent? Where it crosses the x-axis. So now, sketch the graph of the function. Label any relative max or mins on the graph. So we're going to take those answers. You're going to put those points on your x-axis. So we're going to put a point at negative 1. We're going to put a point at positive 1. And we're going to put a point at negative 3. Okay? Now before we graph this, we got to figure out what our end behavior is going to do. So let's think through this. We got to see what's happening to the right side and what's happening to the left side. Now, here's the issue. Our function was given to us in factored form. So since it's in factored form, I don't know right now the leading coefficient or the degree. Does anybody know a really easy way that you could find it? What would I do to go from factored form to standard form? FOIL, but we don't need to do all of it. All we need to know is the very first term, right? So take all your first terms, multiply them together. So what's x times x times x? X cubed. That's all I care about right now. So what is my leading coefficient? Positive 1. What's my degree? 3. Okay, so go back over to your table. Turn your notes over. If the leading coefficient is positive, what does the right side of my graph do? Rise. If the degree is odd, what does the left side do? Opposite, so it's going to fall. Okay, so here's what you're going to do. My very left point is negative 3, right? That means it's going to be falling on the left side. Is everybody with me? So I'm going to fall. Doesn't matter where it's going, just show that it's falling. And then I'm crossing the x-axis, right? I got to cross again at -1. So I'm going to come back down, cross, and I got to cross again. Is everybody with me on what's happening here? And what do I want it to do on the right side? I want it to rise. So after I hit this last point, I need to rise. And that would be the graph of our function. So we don't care what's happening in between. I don't care how high you go or how low you go, as long as your end behavior is correct. Now, let's label our relative max or mins. So how many do we have in this case? We have 2. So I have 1 here, right? What would that be called? Is that high or low? High, so that's a max. Is it an absolute max or a relative max? It's relative. Why is it not an absolute? Say it again. I can't hear you. Yeah, so does everybody see that the graph is going on and on and on forever this way? So it can't be the very highest. Okay? Here is my min. Is this a relative min or an absolute min? Relative, because, again, the graph is going on and on and on, down in the negatives. Okay? Does anybody have a question on that one? All right. Okay, now, there are times when you solve a polynomial that you might get an answer multiple times. Okay, so you might get out x equals 2, comma, x equals 2 again. So if this happens, this means that the 0 is said to have multiplicity, meaning you got it out multiple times. Here's how you know how to graph those. When a 0 has even multiplicity, then your graph will bounce off the x-axis. Even multiplicity, your graph will bounce. If it has odd multiplicity, then your graph will cross like normal. Okay, and I'm going to show you an example of this. So let's just say we get out when we solve x equals 2, x equals 2, okay? So I'm going to just do a pretend graph right here. So there's 2. Whoa. So I'm crossing at 2, and let's say I also get out 0. Okay, so here's what happened. I got out 2 twice. Yes? Does everybody agree with that? So that's an even multiplicity. So what does it say in that definition? If it's even, what will it do? It's going to bounce. So here's what this means. Let's just pretend, again, I don't know what this looks like. Let's just pretend I go through the x-axis at 0. What you normally would do is you would go up here, and you would just cross it, and you would be done, right? If it has an even multiplicity, then it's going to bounce, and it's going to come back down. So it bounces off. It does not cross through it. It will bounce off. And so that's what a bounce will look like. If it's odd, it'll cross like you always cross. Okay, so let's try that. So let's, at example 6, let's find the zeros of this function. So what do I do with all that in factored form? Set them equal to 0. So I have x plus 2 equals 0, x plus 2 equals 0, x plus 3 equals 0, and x minus 1 equals 0. And we're going to solve. all of those. So you guys go ahead and do that. All right, so you should have 4 answers. And what do all 4 of those answers represent? Where it crosses the x. So on your graph, put your points. You have x at -2, and I have that twice. So then -3, and then 1. Okay, I got this answer out 2 times. So what does that mean it's going to do at -2? It's going to bounce. So I know I'm going to bounce there. I'm going to cross everywhere else. But before I can do that, we got to know what's the right side of my graph doing and what's the left side of my graph doing. So this is like what you just did earlier. I'm going to take that function that was in factored form here, so I'm just going to write it. And what's the only thing I need to look at to be able to tell right and left behavior? What's the only thing we need to look at? First term, yep. So you're going to take all of your x's, whoops, and you're going to multiply them together. So what's x times x times x times x? X to the 4th. Okay. So what's the leading coefficient? +1. What's the degree? 4, which is even. Okay, so look back at your little thing. What's the right side going to do if it's positive? Rise. What's the left side going to do? Rise. So that means to the left and to the right, I'm going to be up. Okay, so here we go. I need to start up because that's what I'm doing here. I'm rising. So I'm going here. I'm going to cross at -3. Then I'm going to go back up to -2. And what's going to happen right there? You're going to bounce. So do not cross the x-axis. Come back down. I'm going to cross, and how will it finish? It's going to rise. Okay, so there would be my graph. We're bouncing at -2. We're going to graph, or we're going to label relative mins and max. So how many do we have? So you're looking at your turning points. How many do we have where it's changing direction? 3. So let's go ahead and write them here. So those are my min, right? And this up here would be a max. Turning points are min and max. Yes, Jacob. Uh-huh. Yep. Like you might get out, you most often see it when it's like an x cubed something in your solving. Like let's say you get out 0 3 times. Then you would just cross, you'd put your point at 0, and you'd still just cross like normal. So it doesn't change anything, okay? Okay, anything there? All right, so now we're going to take everything we learned to do these last 2 examples, okay? So we're going to put it all together. So here's what's going to happen. For each of these graphs, we're going to answer the following questions, okay? So let's go ahead and just label them question 1, 2, 3, 4, 5, and 6, and that way we can put our answers easily there. All right, so here we go. Here's our first one. We're going to answer question 1. And question 1 said, is the degree even or odd? So here's what you're looking at. You're looking at your end behavior. They're both falling. They're doing the same thing. So go back to that little table that I gave you. If they do the same thing, if the left side does what the right side does, what's the degree? Even. So anytime they're going in the same direction, it's always an even degree. Okay, leading coefficient. So you go back to that table. Leading coefficient tells you what the right side is doing. Is my right side falling or rising? It's falling. So what's the leading coefficient? If you look at that table, what would it be? Leading coefficient, positive or negative? Negative. Okay, what is the possible degree of the function? So here's what this means. I look and see how many times it's crossing the x-axis. I'm going to go ahead and put points. So it's touching here. What do you notice is happening right there at -1? It's bouncing. So if it's bouncing, how many times did they get out -1 possibly? What? Is it odd if it bounces or even if it bounces? It's even. So they could have gotten it out 2 times, could have gotten it out 4 times. Let's just keep it simple and say they got it out twice. Because, again, we're just kind of making a guess on this or estimating. I crossed again right here. And I crossed again right here. So the number of times that you cross or the number of x's that you get out is your degree. So what could be the possible degree on this one? How many times did we cross? 3 with what? What does that bounce mean? It came out twice. So this means I got out x equals -1, x equals -1, x equals 2, x equals 4. How many x's are we getting? 4. So what could be the degree of this? A degree of 4. Now, it could have been a degree of 6, could have been a degree of 8, but it's at least going to be a degree of 4. All right, domain. Let's look at the domain. Domain is left and right, correct? The width. Is there any limit to how wide this can go? So this is going on and on and on and on. Is it going to continue to get wider as it goes? Yes, it is. So what would my domain be? Negative infinity to positive infinity. Or you could say, if you want, you could just say it's all reals, which looks like this. Make sure you guys know what the all reals symbol looks like. It's an R, capital R with an extra line. Okay, range. Is there any limit to how low it can go for range? No. So it's negative infinity to, whoa. Is there any limit to how high it can go? There is a limit. So does everybody see this right here? That's how high it can go. So it's 4. Is my bracket open or closed? Closed. Then the last thing we're going to do is state maxes and mins, say if they're relative or absolute. So let's do that over here on our paper. How many maxes and mins do you guys see? Anybody see more than 2? Does anybody see 3? Who agrees with 3? Do we agree with that? So I would say 3. So I would say 1 is here, 1 is here, and then 1 is up here. Okay? And just so you're aware, when you tell me what a max or a min is, you're going to say to me it's a max at, and you're going to tell me the y value. So let's go over here to this one. This one would be a max. Does everybody agree with that? Max at, and what is the y value right there sitting on that x-axis? 0. So that's a max at 0. Okay, let's go to this one. Is that a max or a min right there? That'd be a min. What is that at? -4. And then is this one a max or a min? A max. And what is that one at? +4. Now, we got to go in and label these. Are they relative or are they absolute? So just remember, the only time they're absolute is if it's the absolute highest or lowest that it can go. So what about this one? Would that be relative or absolute? Relative. What about the min? Is it a max, or I'm sorry, is it a relative or an absolute? Relative, because it's going to go on forever. What about the max at 4? Good, that is absolute. That's as high as it can go. Chloe. Okay, so why, this is a good question, why is this not a max or a min? Can anybody explain that? So the question is, does it change direction? So you were increasing, right? You're going up, you're going up, you're going up. Are you still going up? At that point, yeah. So that's not a change of direction, okay? Has to actually, if you were increasing, then it would have to actually switch and go to decreasing, okay? So great question. Okay, let's look at the last one. All right, so first question, is the degree even or odd? So you're looking at the end behavior. It's going in opposite directions. Opposite directions. One is falling, one is rising. What does that make the degree? Look back at your table if you forget. If one is doing the opposite, if you're doing the opposite, what is it? Odd or even? Odd. Leading coefficient. So again, you're always looking at the right side of your graph. So what's the right side of my graph doing? Is it falling or rising? It's falling. What does that make your leading coefficient? Positive or negative? Negative. Okay, possible degree for this one. So go up there, and I want you to mark where it's crossing the x-axis, okay? So put points on your graph where it's crossing the x. Tell me how many times it's crossing. How many times did it cross? 3 times. Did it ever bounce? No, so nothing could have come out more than once, right? So what could be a possible degree for this one? 3, yep. So if all it does is just keep crossing, you just write how many times. Just make sure, real quick, your degree matches if you said odd or even. So that would be kind of silly if you said it had to be an odd degree and then you put a 4 right there, okay? So make sure that you're paying attention to that. All right, how about domain? Is there any limit to how wide it can go? There is not. This is going to, don't get caught up in the coordinate plane. It's going to go on and on and on forever, left and right. So what does that make our domain? Negative infinity to infinity, or what else could you say? All real numbers. That's what I'm going to put, just to practice that. Range. So here's what you need to look at. If your graph is going in both directions, is there any limit to my range? No. It can go forever up in the positives and forever up in the negatives. So what does that make range? All real, or negative infinity to positive infinity. Same thing. Okay. Let's do max and min. So go ahead and mark it on your paper, and let's see how many you guys are coming up with. So somebody tell me, how many maxes and mins are you coming up with when you do this? 4? Anybody else having 4 when you see this? Yes? Okay. So let's see if we have the same here. Are these the 4 in green here that you guys are getting? Okay. So let's start the left. Would that be a max or a min? Min, what is the value at it? And you guys just do your best because I don't know exactly. -7, is that what you guys see? -7? Okay, so we have a min at -7. Let's do this one. Would this one be a min or a max? Max at 5. Okay, let's do this one. Would this be a min or a max? Min, what's that one at? 3. It's kind of hard for me to read up here, so I'm just trusting you guys can tell better. And then this one, min or max? Max at 6. Yeah? Does that look like 6? Okay. Okay, now we need to label them relative or absolute. Before we even do that, I'm going to say right now, none of them can be absolute, and how do you know that none of them are absolute? Because why? It's going both directions, right? It's going forever up in the positive. It's going forever up in the negative. That means none of these mins or max can be absolute. So every single one would be labeled as relative. So make sure you're paying attention to your graphs. Okay? All right. Any questions for me? It's a lot of information, I know. Keep your notes out. You're going to want to have these out as you do your homework. Your assignment is on Canvas, and you may do this assignment up to twice. So if you don't like your initial score, you can do it again. And if you have a question, I will be around. Yes, Chloe. What sign? The real, all reals? It's just like a this, and then do an R.